Welcome, everyone. Welcome to the fifth and final day of the second annual Fatty Acid Symposium. My name is Kelly Patterson. And before we get started with Dr. Peoples and his session on omega-3 in athletes, I just want to make a few housekeeping announcements. First of all, if you have any technical questions, please submit them in the chat. If you're having issues with hearing or seeing the presentation, we can try and troubleshoot those. If you have any questions about the presentation that you would like Dr. Peoples to answer at the end of the presentation during the Q&A, please submit them in the Q&A. We also, if you've joined us on any of the other sessions this week, we'd love for you to put where you're joining us from in the chat. So, go ahead and tell us where you're at. We'd love to see the global presence during these webinars. If you are having trouble using the chat or the Q&A function or any other issues, please reach out that you can't access in the webinar. Please reach out to Becky with your questions. Her email is becky@omegaquant.com, and we will put her email in the chat just in case anyone's having any trouble there. Also, please consider a donation to the Fatty Acid Research Institute so they can continue the important research they are doing on fatty acids in health. Becky has put information about donating to FARI in the chat, so please take a look at that when you have the chance. Also, there will be one final session after this, which we hope you will join. This will be a live panel session, which will include several of the speakers from this week. It'll include myself, Dr. Bill Harris, and Dr. Heidi Lai. If you haven't signed up for this yet, Becky will put the link in the chat. Seeing people from all over the place. We got South Florida. Let's see what else. Arizona, Colorado, California, Colombia. Keep on putting out where you're from. We'd love to see everyone from all over. Finally, I want to thank all of our symposium partners who have helped us spread the word about this event, including Omega-Quant, GoEd, Parasol Nutrition, Carlson, Nordic Naturals, Yoli, GC Reber, Viva Omega, Dr. Sears, Zone Labs, Dr. Boz, and Nutridyne. So thank you, everybody, for joining us. Got some more. We got some folks from Canada, the Netherlands. That's awesome. Ireland, great. All right, we're going to go ahead and introduce our today's speaker. This session's speaker is Dr. Greg Peoples. Dr. Peoples is an exercise nutrition physiologist and research academic in the Graduate School of Medicine at the University of Wollongong, Australia. His PhD thesis demonstrated the physiological role of omega-3 DHA to enhance skeletal muscle fatigue resistance. In the last 2 decades, he has expanded his omega-3 research to include topics of cardiovascular, inflammatory responses, exercise recovery, and muscle soreness. This includes the biomarker-informed relationship between the dietary intake of EPA and DHA and the omega-3 index in physically trained groups. In addition to laboratory trials, he has conducted translational research in professional cyclists at the Tour de France, international rugby players and union athletes, NCAA football players, and the military. Dr. Peoples is also the author of the Australian Institute of Sport Supplement Fact Sheet for omega-3 fatty acids and a leading collaborator on an Australian study that describes the omega-3 status of Australian elite, professional, and Olympic athletes across more than 30 sports using the biomarker technique for fatty acid profiling. Dr. Peoples, thank you for joining us, and we really are looking forward to your presentation today. I'll let you take it from here.
Excellent. Thanks, Kelly, and thanks for the opportunity to present. So if you don't know, I'm from Wollongong, which is an hour south from Sydney. So we're a small little coastal town with a university sort of nestled into the escarpment behind. So if anyone's over this way on the East Coast, we're currently 4 o'clock in the morning here, but you're more than welcome at any time to come and visit. So I've got no conflicts of interest in terms of the supplement industry, but I do some private consulting around some omega-3 with athletes and teams. So in terms of the learning objectives today, we're going to cover a range of different topics, and I'm aware that this topic was also covered last year, which Jeff did an excellent job for. And so I've really sort of looked at how we can sort of change this up a little bit and have a look at it from a slightly different angle on a few different occasions. So we'll cover off on some physiological roles as usual, have a look at some clinical and sports nutrition research, really have a deep dive into the omega-3 index, test and how it works. And I've got 4 case studies that I'd like to present towards the end of the talk today. Start to dig into some of the evidence-based recommendations that we have. And as mentioned, we've got a really interesting framework here in Australia from the Australian Institute of Sport, and Omega-3 and fish oil has actually been able to be listed on that, and I'll go through that as well. And in terms of, and I call it flipping the coin, I'm going to actually have a look at some industry claims as part of this as well, and really determine how that is lining up against where we are in terms of the research in this particular area. Look, I'm a little bit of a historian in a way, and I really like the idea of going back and really tracking, on a particular research theme, where did this all start? And so what's really interesting is that we go right back to the late 1980s. And so this is Alexander Leaf, and it's a study that's often overlooked, but it's actually one of the first mentions or studies that considered whether there was an interaction between intake of omega-3 and exercise physiology. So in this particular study, a range of cyclists and runners and rowers were all randomized to 3 different groups. And so Professor Leaf had a high dose group, a low dose group, and a placebo. But you can even see with the number of capsules per day and using Promega, we were still looking at, in the low dose group, between 2,500 milligrams per day, and the high dose was really sort of kicking up towards the 4,000 milligrams per day. I had these endurance athletes, let's call them, supplemented for 6 weeks. And the other really important thing, and I'll touch on this as we go through, is understanding what was the basis for this. And so the idea was that the omega-3 would be incorporated into the membranes, which we all nearly take for granted these days. But the concept was that when red blood cells are squeezing through capillaries, the idea is they deform and they release the oxygen at that point in time. And so the concept was asking the question is whether or not that would improve the aerobic capacity of these endurance athletes. Now, an important part to it, it was an estimated aerobic capacity. And there was a report in this small group that the aerobic capacity was increased. Now, what was interesting is the observation was statistically noted in the low group and not quite in the high group, and the data was never combined. But it certainly increased that conversation, at least started the conversation in this particular topic area. So if we have a look at the relationship between 1988 and now, and we have a look at the number of publications that are specifically targeted omega-3 and fish oil in trained groups, exercise physiology, performance, and athletes, we can see it was pretty quiet really for the next decade or so. But at the turn of the century, we can see that the conversation really started to open up, and the ideas were starting to flow from that particular study in some ways. And we get a real rapid acceleration of research in this, and we're not so this area, what we're saying is physically trained groups, because often we see a lot of research in university students and undergraduate students and so on, but these were actually nominated as trained individuals that were being studied in these cases. So if we go through and have a look at those particular studies, we're reaching close to 50 at this point in time. Just over half of them with double-blind randomized controls. What's interesting is, again, like we see in most exercise physiology, there's a dominance towards males. The mode of delivery, as we'd expect, is capsules, but as we start to come forward towards present day, we're still obviously seeing food science and technology deliver that through drinks, for example. The one that we're really interested in is the idea of being able to determine that the compliance and the uptake of omega-3 is present in these studies. So if we actually have a look at the types of cells that are tracked, it's only really about 50% of studies were looking at some form of cell to determine whether that omega-3 was actually being uptaken. And in terms of source, of course, most of it's been fish oil with some krill, and then we see a scattering of other mediums such as seal oil or New Zealand mussel as well. The other interesting part I always like to look at is to determine how does the conversation flow in this topic. So if we started at that aerobic capacity study from Alexander Leaf, what we notice is that very quickly we get a range of different body systems starting to be considered. So if we consider sports performance, very quickly there was a study done in the late 1990s that considered whether soccer players actually increased their aerobic performance as well. And that was really off the back of Alexander Leaf's study. Very quickly, we also see the delayed onset muscle soreness, but we see a really ranging number of topics spreading very quickly. So we've got the respiratory system, immune cells. Coming forward to some of my early work in sort of just the turn of the century, we're starting to look at the cardiovascular system a little bit more specifically. Reaction time in terms of the neurological. Back to us, we had a look at some heart rate recovery in sort of around 2014. Obviously, with the omega-3 index really starting to take hold, we've got Von Schacke's study in our German athletes in 2014, some really established neuromuscular function studies by Lewis's group. We've got some prophylactic DHA and concussion, and then we've now seen some really good work from Chris McGlory around muscle protein synthesis, particularly in the unloaded state. So this distribution of topics has gone from what was an aerobic capacity type question and very much expanded into all the different body systems and different tissues, which is fantastic. And obviously off all of these studies, we've got more conversations and more studies that have actually been born out of that a particular theme. What is also interesting is if we have a look at when the first review was done, this is Professor Simolopoulos from Greece, that in 2007, we've got this first idea of sort of trying to come up with a collective thought about how this interaction between omega-3 EPA, omega-3 DHA is working. And so this is a really nice, it's a short review, but it's a really nice review that tries to draw in some, I would say, ideas, because at this stage, if you think back a slide or two, there wasn't many studies actually in trained groups at this point in time. And so drawing from inflammation, the cardiovascular system, metabolic health, and trying to apply some sort of question or hypothesis around how it could actually potentially help trained individuals and athletes was first sort of documented in some form of summary in 2007. What's really interesting is that she actually nominated 1 to 2 grams per day of EPA in her study, but the ratio in this instance was 2 to 1 for EPA and DHA. And we know now coming forward that we've got a lot of conversation around the individual effects of these two fatty acids as well. But it's a really important position, I think, in this particular theme around trying to collate the ideas at that point. But equally, it's very early in those days. If we actually have a look at the number of reviews that have taken place, they're actually keeping pace with papers now. So what we've got is in trained individuals up to about 50 papers looking at this concept of omega-3 interacting with athletes and recovery and exercise physiology. But equally, we're seeing a rapid uptake or rapid production of reviews. And you can see that, about 3/5 of them are thematic, but we're starting to now see some SLR and meta-analysis, which is actually really important. And it's a point that I'll sort of continue to make during this talk, is the idea is that we weren't in a position 10 or 15 years ago to be able to start to really join some of these studies together, but this is starting to occur, and I think the next decade is quite exciting. So if we have a look at the topics, the thematic reviews generally look at performance overall, but we're seeing that DOMS and inflammation really start to take hold. Hypertrophy and strength has been quite popular. The conversations around injury and cognition. SLRs, in terms of being able to pull together commonalities between studies, body composition, again, performance, omega-3 index is starting to play out because obviously more of us are collecting this now, so we can actually join those studies together. And again, cognition. And in terms of meta-analysis, DOMS and inflammation has pretty much led the theme at this point in time, which is interesting, isn't it? Because where it started was this idea that we can improve aerobic capacity. But what I really like about this is that the different body tissues, because of the idea of the membranes being able to be modulated through the provision of EPA and DHA, we've now got lots of conversation in different systems. And what's interesting is that the muscle has become quite a common theme in this particular area. But it is a bit of a classic snail's pace, and we all are pretty used to that in the research area. So if we go back to our early review, it talked about being balanced between omega-3 and omega-6, and it also really sort of opened up the conversation around sort of we should be reducing omega-6. Now, if we now know that it's really the provision of omega-3 that we should be focusing on. It's not that there's, not good reason to think about omega-6 in terms of its benefits as well. And in some instances, it may be quite high in the diet. But we do know that the provision of omega-3, particularly those two fatty acids, EPA and DHA, is really critically important despite the background diet. Coming forward, we've got human data inconclusive in 2013, and it kind of makes sense because we really didn't have enough in these trained groups to be able to make any decent conversation around this. But very quickly, in sort of around about 10 years ago, we've got the idea that the anti-inflammatory, antioxidant activity might be involved. But we've still got the challenge that a lot of papers that are beyond the 50 that I showed you before do include amateur athletes. And so that translation up to some of these really high-end professional athletes with large training demands can be quite tenuous in some instance. And we've also got currently some inconsistent translation into clinical endpoints. And I'll talk about this as we go through as well. So I just want to flip the coin for a moment, and this sort of makes a different approach. And this is a study that we're currently doing at the moment, and we'll just give some preliminary insight to this. What we've done is actually looked at the omega-3 industry. So from the point of view, if we've got growing research that is supporting the idea that there is a range of different reasons that a training athlete could make use of omega-3 as part of their diet, what is the industry looking at here? So what we've done is we've done a search just like you would do for a lit review, but we've done it from the point of view of what is available. We've also looked at whether or not these supplements are certified in any way. So there's a number of large organisations that actually then put these batches through rigorous testing so that there can be some form of confidence from the athlete that it's not contaminated in any way. And it's really important for professional athletes to be able to do that. So we've come up with 50 brands so far that are currently on the market. And so what's interesting is it's, within reason, majority are capsules, but we've got a combination of mixed capsules starting to appear as well. So that's an omega-3 with a vitamin D or omega-3 with another antioxidant. But what's also interesting is that the food science industry is able to now deliver that through drinks. So of those 50 major brands that we identified, we've now seen an increased proportion of drinks being available to the sports nutrition market, let's call it overall. If we go through and have a look at what is being cleared or batch tested, you can see that we've got a range of different organisations that are actually doing your classic audits on these products, and those products can then be badged for athletes and sports dietitians and nutritionists to be more confident around the clearance and the non-contamination. What's also interesting, we found out of that 50, we found 5 that had no clearance at all in this instance. In terms of the delivery, of course, we see a lot of fish, but we're seeing the increased provision through algae now, and there's some examples on the market through krill and mussel oil too. In terms of the major delivery mode, again, the proportion is fairly high in terms of the triglycerides that are being used, but we've also got examples of classic phospholipid delivery, and in some instances, there's no specification at all. What we've done is we've had a look at the packaging, and we've had a look at what per unit the amount of DHA and EPA that's being provided through any of these particular sports nutrition supplements. And so what we've got here is per unit could mean that it's a 1 gram capsule or 1.5 gram capsule, for example, or it could be, if it's a drink, it's a particular volume of fluid. So we could be looking at 200 or 300 mils in this instance. So you can see that on average, if we have a look at the ratio between EPA and DHA, is that it is by majority higher in EPA compared to DHA. So that's that classic 18-12 ratio that we often see. But what you can see here in the darker circles, these are products that are actually the opposite. So we are starting to see some examples where DHA is the more predominant and sometimes the only fatty acid that is being advertised on the side of these particular products. The last thing that we've done here is we've taken the concentration or the amount of EPA and DHA per unit, and we've multiplied it by the recommendation of how many of those should be taken per day. Now, this is really interesting for us. because what you can see is a really wide range of recommendations from the sports nutrition supplement industry. So we've got everything from under 500 milligrams total all the way up to around about 5 grams. So in other words, there's a full scattering of how much we are being told that we need to be able to be intaking on a daily basis to improve any of the particular themes that the sports nutrition industry is pushing towards us at any one time. So on that topic, we actually managed to put in what we call the front of shop marketing. So you can see this is just a classic density diagram, a word cloud, and the immediate ones that jump out straight away in terms of the front shop marketing are high strength fish oil, omega-3. Little bit of interesting wording around performance, even at the shop front. But if we go a little bit further and say, which of these brands actually claimed something based on athletic performance and do the same activity, we can see a range of different claims that are being made. But the one that's really interesting is that muscle stands out to be one of the most common tissues that the industry is claiming they can help. And behind that, we see words such as performance and recovery and athletic recovery sitting behind. For me, what's really interesting from a cardiovascular point of view, knowing where this really is borne out in terms of the cardiovascular disease story, is that we don't see too much evidence around claims on heart and vascular in this instance. So the industry has very much swung towards the inflammation, muscle, soreness, performance and recovery as the major claims that they're looking towards in terms of being able to market to athletic groups and sports dietitians at any one time. So this is some work we did with Jeff a couple of years ago, because what we're looking at then is, if we've got all of these claims, how does it stack up against the evidence? And so what we did in this particular study is we reviewed not only the trained studies that have delivered omega-3 in any form, but we actually looked at the study design considerations. Now, this has been obviously a very well-spoken topic in cardiovascular disease, but we figured at this point in time we needed to make sure that that conversation translated over to what essentially can be siloed groups of scientists. So in terms of exercise physiology, we thought it was a really important topic to be able to do. So what we did in this instance is we looked at the concept that obviously when studies are conducted, they're providing an omega-3 in some form, and that is absorbed into the circulation. But really the first base is the idea of coming up with a key marker to determine that compliance is good, but also determine that we've got good randomized control allocation to the point where we also know that we get good separation between the groups, and being able to confirm that's really important. And being able to confirm that means is having a look at from the point of view of the hypothesis of cell membrane incorporation into the tissue. So not just simply trusting and knowing that someone is intaking this, but the idea that they're intaking it consistently, whether it's EPA or DHA or combination, and consistently to the point that we can actually perform the omega-3 index test in this instance to be able to determine that we've actually got good compliance and we get good separation between control and intervention groups. And obviously that is a reflection of the different tissues, and what we'll do today is sort of talk a little bit about each of these different tissues in turn. So what we determined in this particular study is that if we look at the RCTs, the RCT crossovers, or those that were non-randomized control, there was a moderate to serious risk across all of these. But we went one step further, and this was actually a PhD student of mine that was leading this, Ryan Anthony. We actually then took from the cardiovascular theme around what is good study design, and we applied that as well. And so we had these 5 criteria to determine whether or not we'd actually, these studies had performed the research in a way that we could be a little bit more confident in the actual delivery of these omega-3. So we looked at exclusion of participants from baseline, whether the supplementation related to a change in erythrocyte membranes, exclusion of participants on supplements, consuming 1 or more fish meals per week, and also looking at the duration, the idea that if the hypothesis is a membrane change and therefore will push forward into tissue, that we actually do have some level of provision over a period of time. So we set 4 weeks as the minimum in this instance. And in this study, we showed that really very minimal, around about 1 to 2 studies really, each study only ticked off 1 to 2 of these points. So in other words, that a lot of the learning from the cardiovascular industry really hadn't come across to the exercise physiology. So we've sort of been pushing the idea of trying to increase the education of researchers in this particular instance, so we don't end up with research waste, is the best way of putting it. Another really interesting point that we made here is that, and it really sets the idea of the hypothesis, as we looked at the EPA and DHA provision in each of these studies and how many days the supplement was running for. And you can see that there was really no relationship at all. So in other words, we've got very high doses for short periods of time and equally the opposite direction. So in other words, there was not a lot of hypothesis setting being done in these particular studies. And that was a little bit concerning for us, particularly when we're talking about trained groups and then making claims across to whether it improves recovery and performance and all of these, the things are really tricky to actually measure anyway in any one time. So just quickly, we did come up with a recommendation and we've pushed that out to the exercise physiology industry over the last year or two, just making sure that within reason we can go through a process that when we're doing studies in the future, we do recruit properly, we do screen participants properly, we do make sure that we end up with inclusion, and we also end up with the idea of separation of groups. So I've sort of said this on the basis that we are taking for within reason, the studies that have occurred have been good, but we're really wanting to make a bit of a change in this industry so we don't end up with this research waste going forward. All right, so if we flick over to the different tissues then, I want to cover off on not all of them, just for the sake of time, but we also had a similar talk last year from Jeff as well. So I've sort of modified this a little bit so we can sort of look at it from a couple of different angles. I just want to make an early note here, and I'll come back to it. As mentioned, we've got the Australian Institute of Sport in Australia here, and it's got a supplement framework that was born out around about 15 years ago. And what that does is it looks at the quality of evidence from different research studies. And for Omega-3, it's branded as fish oil in the actual supplement framework, but it's a Group B. And just to quickly explain, the Group A supplements are the highest level RCT meta-analysis type level. B is pretty much emerging at this point. And then we also have a C, which is new, a lot of questions still being asked at this point in time. So this stage, Omega-3 fish oil has been grouped B, meaning that we've really starting to see some interesting papers come out, but we really need to see a lot more sort of collective evidence around that high level meta-analysis to be able to sort of move forward into Group A. All right, so what I want to do is just go through 3 of the major systems. So if we start with the cardiovascular system, and this is sort of one of the favorites of mine, what we have noticed from the untrained participant industry is that the idea that we can modulate heart rate. And so this is an interesting one when it comes from the point of view of athletes that are within reason also modulating their heart rate through their training. And so the idea is that we know that when we train, the stimulus of exercise training is already strengthening our heart, it's already lowering our heart rates. The question of whether you can further that effect through a nutritional plus exercise stimulus is really, really interesting. So this was one of the first studies that I conducted back in sort of pre-2008 here. And so we looked at whether or not fish oil reduces heart rate and oxygen consumption in trained cyclists. In those days, we were using around about 8 grams of fish oil per day for 8 weeks, and that brought in a high DHA content. So again, to emphasize, we've sort of really focused on DHA as our critical fatty acid as opposed to EPA. And what we did is we obviously performed VO2 max tests like you would, but we also set them off on endurance tests here, and we collected heart rate during steady state cycling over a long period of time. And after the 8 weeks on this high DHA, which is around about 2 grams per day, we observed a heart rate reduction, and this is in trained cyclists. So these were cyclists that were competing at a national level, and we saw it at a quite significant amount. So this is what we're seeing is more than 5 beats per minute and up to 10 beats per minute on average over a prolonged period of time. And so this were essentially time trial type episodes. The other thing we did is, because it was a cardiovascular interest study, we multiplied the heart rate by the systolic blood pressure at any one time, and this is called the rate pressure product. And the rate pressure product is an indicative of myocardial oxygen consumption. And the theory here is that the DHA being provided to heart cells, and we've seen this in animal studies as well, actually improves the oxygen efficiency of this particular organ. And so what we observed here is, over a period of time, the steady state cycling, the rate pressure product was also seen to reduce in this particular group as well. So what we can confer from that is that the myocardial oxygen consumption was also being improved in terms of its efficiency. One of the interesting topics, and again, we've seen evidence in untrained individuals that heart rate recovery can be improved with the provision of omega-3 and particularly DHA. We're also interested from the point of view of whether or not that could be an additive effect during exercise interventions where you've actually got trained individuals as well. And in this particular study, we used a very sort of powerful cycling repeated burst activity towards peak heart rate and then a sustained time trial. But what we were interested in is whether or not providing DHA again at a more predominant level. So this is 540 milligrams per day versus EPA down at 140 with a provision of just around 700. We looked very closely at the heart rate recovery from peak levels. And what you'll notice about heart rate, it obviously doesn't come down in a linear fashion. What you can see is that we performed at what we call a logit regression from that, and that the, again, trained cyclists that were on DHA for this period of 8 weeks improved their heart rate recovery by about 8 seconds. And the point that I want to make is this is in addition to what is a very well-functioning cardiovascular system in these trained athletes. So now we're seeing the potential to have additive effects through the diet with a particular emphasis on DHA at this point in time. So enhanced heart rate recovery has become one of the interesting topics that we're starting to sort of push a little bit harder on here. But like usual, we want to make sure that we can sort of push that up to a really applied level. So this study also occurred in Australia around the same time, and it was over in Adelaide. And again, it was a high DHA oil that was fed to, and this is a sport that we have in Australia called Australian Football League. So these athletes can run up to 20 kilometres during games, which the ball is moved from one end of the field to the other. So they're very, very endurance trained in this capacity. They're also a contact athlete, so they're tackling and they're pushing and they're shoving. So it's very physical game. And so these athletes were provided with, again, a high DHA oil for 5 weeks in this instance, and their heart rates were looked at after 5 weeks on a submaximal treadmill activity, so essentially running at a fixed treadmill speed. And the observation is that we have a heart rate reduction in what is already a very fit, aerobically trained group. So if I sort of push that into, and you can sort of see where I'm going here, the idea of, are we seeing some sort of pattern? If we collate some of those studies together, what we can see is there's some commonality starting to play out. And this is another point that we're making, that we're starting to get to the point where we can pull these studies together, have a look at it from the point of a systematic literature review, and also, where possible, we should really be targeting some meta-analysis at this point in time. So what's really interesting as we go through, most of these studies are in trained individuals, but there is a theme that DHA becomes the predominant oil on each instance, and where DHA is not the predominant oil, or EPA is only provided on its own, we're not seeing changes to some form of heart rate physiological measure. So this one, there was no change in submaximal heart rate. The study out of Poland was interesting. There was a high EPA, but there was no effect on heart rate, even though the DHA had been provided at close to 1,000 milligrams, which would match up to some of these previous ones that we've seen. And the most recent one was only published last year. This was a mixed endurance athlete study out of the UK. And this was interesting from the point of view that it was a mix of EPA and DHA in both instances, but they had a high DHA group compared to EPA and a high EPA group compared to DHA. And when those two heart rate reductions were looked at, the higher DHA group showed a more powerful effect. And in fact, it was very similar to what I'd seen in 2008. It was around 8 or 9 beats per minute during exercise, compared to around about 4 or 5 when the EPA was more dominant in this instance. So this is a really good example where we're actually at a point now where we can start to conduct some more intricate SLR meta-analysis. And you can sort of see that this is what I'm really pushing in the industry. I'm going to jump across to skeletal muscle because, as you saw from the sports supplement side of things, they're very much pushing that. And so one of the themes that started in 2002 was this idea of reduced muscle soreness. Now, this is a classic study from a pre-season in elite rugby union athletes from New Zealand, where they were provided with a supplement over the course of the 5-week pre-season or a placebo control. And those that were on the Omega-3, adding up to approximately 1 gram per day, reported reduced muscle soreness over that period of time. And obviously, when they're coming back in the pre-season, they're very used to being very sore during that sort of established adaptation mode. And that there was some maintenance of power and explosive strength in these rugby union athletes. Now, the challenge with this is obviously it's a field study, and so we've got examples where that is needing to be a bit more tighter. So on the point of view of inflammation, what we're really trying to do is incorporate these 2 fatty acids. And when athletes are constantly going through training in terms of inflammation spikes and recovery, the idea is we're trying to make sure that this baseline inflammation is in control in some way. We've just published a review on this in Sports Medicine, if anyone wants to have a look. And so the idea is that, obviously different types of muscle contraction, particularly eccentric contraction, can do some decent damage to those peripheral cells. And if we have a look at the incorporation of the membrane, particularly for EPA and DHA, we're seeing some really good example now where the pro-resolving mediators are becoming really important in this conversation. So rather than just talking about it as an anti-inflammatory effect, we should actually be sort of looking at it as a total physiological process, which includes the pro-resolving components to that. In terms of the muscle soreness studies or research, we published a paper or report about 3 or 4 years ago where we sort of collated those up, not to the point of a meta-analysis, but certainly a systematic literature review. And we tried to point out that some of these study design issues might be getting in the way even in this topic as well. A lot of the studies were cross-sectional, the recreational active athletes, fish oil broadly rather than EPA and DHA was being looked at, and very limited biomarker confirmation. Now, in saying that, if we look over towards where the themes were playing out, there is some overall observation that the rugby union study that we've seen is starting to be reflected in more lab-based trials where the report of reduction in pain and reduction in soreness is starting to occur. We have got 1 or 2 SLRs that have occurred that have pushed through to a meta-analysis, but I will nominate that the studies that have been put together so far haven't looked to determine whether any of these studies that are included have actually followed some good study design evidence around designing omega-3 studies and making sure that we are tracking that intake and compliance and biomarker. But in saying that, we do see an increasing theme around favouring omega-3 in terms of reduction in pain. And that's a really good conversation that we're having, that there is some mechanistic idea that particularly DHA in particular could be a pain mediator in some way. And it's beyond just sort of muscle damage, it's dental pain. There's a range of different themes. Now, Jeff's done some excellent work over the course of his PhD, where he's actually then started to divide out EPA and DHA. And his particular study that he published a couple of years ago, he also reported a reduced muscle soreness or delayed onset muscle soreness when EPA and DHA were separated. Now, this was an excellent study because it really bore out the idea that we shouldn't just be treating it as fish oil, that we should actually be starting to look at these two. Now, in saying that, we also observed that there was some a loss of this effect when these 2 fatty acids were actually given in combination. But it was an excellent paper from the point of view that it actually said, let's start to look at these fatty acids individually and let's look at them on their own merit. So we've just finished a PhD study where we pushed on from what Jeff has done, where we have supplemented DHA at 715 milligrams per day, and we've done it through a chewable tablet, and this was with collaboration with Omega Ingredients in this instance. Just to comment on this, our lab has been very interested in the 500 to 1,000 milligrams on the basis that if we're coming from low population intake, we really want to know about what is that first step? What do we do? What do we observe when we go from low intake and we push it out towards that meeting 500 and 500 to 1,000? And it's a really important conversation to have. So rather than just ramming doses up to 3,000, 4,000 milligrams per day, it's really important we understand what is the first step. Do we actually see observations when we actually make an immediate change and that small effective change? And so 715 was delivered. You can see that over 12 weeks, we clearly separated the groups. We took a different approach to delivering muscle soreness. We've got an eccentric cyclogometer. And so essentially there's a motor that drives the pedals backwards. And so the participant has to resist those pedals and it makes their lower limb muscles very sore. And the other difference is that over 12 weeks, we're able to do a pre and post. So we've actually got a control group where a lot of these studies have just simply been cross-sectional at the point of the post supplement. So in this instance, we were able to drive up soreness and we were able to repeat it in the control group. And this instance, we see a reduction in DOMS in the DHA group. Now, one thing that we did do is we recruited as a 2-to-1, and half of this was delivered through an algal DHA and half of it through a fish, and then we combined those data together. So we were able to be separated as well, and there was no difference between the algal and the fish in this instance, which gets us back to the industry that we are starting to see increased provision of sports supplements through algal-based sources as well as fish. So area under the curve was reduced for the muscle soreness in the DHA group compared to the control. We also looked at performance, and we can see that, classically muscles are sore, performance goes down for counter mover jump and mid-thigh pull, but that was attenuated after being on the DHA. So in other words, the ability to return in 48 hours was a little bit, was augmented, was a little bit enhanced compared to the control group. So less sore, returning to function a little bit faster with DHA only. And that's a critical point. So, I'm emphasizing that Jeff really started this conversation around separating it, and we're hoping that we've pushed on a little bit further to actually show that that's, we're supportive in that instance. In terms of being able to then create a mechanism around that, Chris McGlory has done some excellent work. So we'll just nominate quickly that when a high dose omega-3 EPA and DHA is fed and muscle biopsies are taken, we can see that the omega-3 index is actually a confirmed really good tracker or marker for that. So we can be more confident that we can use the red blood cell membrane across and make inferences about tissue like skeletal muscle, and that you can see that the washout in terms of being able to track that over weeks once removed is evident as well. In terms of skeletal muscle, we've done some work, and this is in animal, looking at whether or not muscle biopsy is all muscle fiber types together. We've considered whether or not there is a difference according to muscle fiber type itself. And so in this study, it was an animal study, but we looked at control, a low dose provision of DHA or a higher dose provision of DHA. And there's a really good relationship to the proportion of fast oxidative glycolytic fibers. And so what's interesting about that is that these are the fibers that sort of sit between the slow fatigue resistant and the fast powerful muscles. They've got high mitochondrial content, but at the same time, they can be quite ballistic. So their job is really to create force over a period of time, and also do it in a way that it's aerobically charged. And so what we can see is that whether or not it's a control or a low dose or high dose, is that as the proportion of fiber types towards the fast oxidative glycolytic go up, the DHA that's incorporated into those cells is actually increased as well. So how does that play out? Well, again, back to some of the work that Chris has done here. This is an excellent study looking at the applied nature of how to deal with the physiological stress of immobilization. So for athletes, the classic is injury. It's coming back after being mechanically unloaded. They haven't been able to perform the same gym functions that they normally do. They're not training, they're not competing as much, and obviously their muscle atrophies over that time. So Chris provided his approximately 5 grams for 4 weeks, immobilized, and then looked at recovery. And what was really evident with that is that we see the atrophy in both groups, but the atrophy was less evident, and the return to muscle size was a little bit quicker, let's say, in the group that was preloaded with omega-3. And so if we consider that from a point of view of muscle protein synthesis and whole body protein synthesis, we've got a couple of SLRs and meta-analysis that are up here. But again, it's the reason why I showed you the number of studies is really important, and the number of reviews is really important. We're only really now starting to get to the point where we can collect this evidence together. So we've got a couple of studies here in this SLR and meta-analysis that demonstrate there was no evidence on muscle protein synthesis per se. And this is with Ollie Widdard's group out of the UK. There was some emerging evidence over whole body muscle protein synthesis in this instance. So I think it's going to be an emerging theme at this point. And again, a theme that if we really concentrate on being able to design these studies well, we should be able to see some nice supportive evidence to move this topic forward as well. The last one that I want to do before moving back to the supplement side of things is the brain side. And so this was a study that we did with Jeff, and Jeff kindly did the work of collating some data around 3 particular studies that had looked at providing an omega-3 across the course of contact sports season. And in this instance, we ended up with around about 105 contact sport athletes that were on omega-3 compared to placebo 71. There are obviously some limitations to this. Yes, there was raw data, but each of these studies were designed in a slightly different way. When we looked at the baseline neurofilament level over the course of the season, so mid-season and post-season compared to pre, those that were provided with an omega-3 obviously were less inclined to increase that baseline inflammation that's coming from the neural cells. But at the same time, there's some real need for this to push forward. Now, what's really encouraging about this is out of North America with Tim Mickleborough's group, they're actually performing the first proper RCT right now. So in about 18 months' time, we're going to have some really good evidence starting to come through in this particular topic. So I think the conversation around brain injury has certainly developed, like most of this literature, and now we can start to really design these studies to be able to answer those questions more specifically. In terms of future directions, where I really see this going is in terms of being able to ask more questions around the immune system, the soft tissue and unloading and injury states, sleep, and then gut health are going to be really important. In terms of the female athlete, we're having really good conversations here in Australia at the moment around the female athlete, not only from the point of view of pregnancy, but in terms of menstrual cycle pain is actually one of the really interesting topics that I think will develop at this point in time. So to finish with, over the next sort of 10 minutes or so, we're just going to have a look at whether or not we actually do have omega-3 being intaken in athletic populations. So again, Jeff was able to collate a nice SLR in this instance, looking at the range of omega-3 index across a range of different sports. And then Jeff and I actually got together on the military side of things as well and looked at the same sort of topic. And what you can see is just like the background population, athletes are no different. Okay, so we've managed to also now provide, and this is unpublished, but certainly we're going to be publishing it this year, an Oceania screening at this point in time. And what's interesting about this is that in Australia, we're starting to increase a little bit compared to what we can see from the rest of the studies that are already published. And as I pointed out, there's a sort of an interesting sort of conversation that's occurred here in Australia that if we go back to the Omega-3 Australian Sports Institute framework, these are fact sheets that are available to all the sports dietitians, all the athletes, and they're actually used to be able to translate and educate across the Australian context. So in saying that our average is looking to be a little bit higher than some of the previous work, part of it is that we actually do have a decent amount of educated material that's actually provided at a sports dietitian level. Not only is it about supplements, but it's also about whole food intake. And so this is the classic where we actually see some good examples of whole foods also being used as an educated process rather than just the classic capsule. But if we have a look at what is the recommendation at any one time, there's really only one particular consensus that has actually come up with a level. So if we think back to the 2007 review, it said 1 to 2 grams. In this IOC consensus statement from 2018, it came out as broadly 2 grams. And it was just a broad recommendation around omega-3, nothing about EPA and nothing about DHA. And so what we've done here is we've able to sub in the omega-3 index into our fact sheets and actually provide alongside, generalized recommendation, some minimum targets. And this gets us back to the idea of if the background intake is quite low, well, let's see if we can get into that first target zone. So here in Australia, what we've got is the first target zone, 500 to 600 milligrams of EPA, really starting to get the baseline level raised, and that potentially could be part of the reason why we're seeing a slightly higher omega-3 index in this part of the world athletes. Let's have a look at some case studies now. So if we go through and look at the population, there's our first study from von Schacke in 2014 with our German athletes, where we're starting to see a scatter now of different elite sports, and we're sort of seeing a common theme that they're sitting between 4 and 6%. And also a Spanish soccer team as well. Here's our study from Australia that is unpublished at this stage, but we're aiming to publish it this year. We've got close to 600, and we're pushing a little bit higher towards 6% on average, with a good span out with some nice evidence that we're increasing our frequency of athletes up into towards the 8%. Let's have a look at some real case studies, and we'll do that based on just check my PC for some reason. I think it's all right. So this is a provision of omega-3 with an Australian elite rugby group here. And so what we did is screened the Australian rugby squad. And you can see that in the males, we had a close to 6% on average, and the females were a little bit lower at towards 5. And this in context to previous rugby studies that were all under 5 at this instance. So again, we've got a little bit of theme here in Australia that the omega-3 index is coming out a little bit higher. And part of that anecdotally is that we are seeing a push of education throughout this particular area of the world with athletes, and that's starting to play out. If we have a look at the males and females, the females in terms of whole blood EPA and DHA was lower. And again, it can come down to equivalence and also equity, that we're seeing more evidence for males being provided with supplements and more evidence for males being provided with education compared to some of the females. In terms of provision, we've done a small study here in Australia where we looked at what does it actually take to make a change, and in a real world situation, how effective is that change? And so this was a group of rugby league athletes, female professional athletes, and you can see at baseline here, we've got the classic low omega-3 index, and we provided them with one of the screened informed sport supplements. But in this instance, we just provided them with the education and we provided them with provision. And what we noticed that is over that period of time, we got a real large spread of results. So in other words, the omega-3 index range from not changing much at all through to changing, and also the AA to EPA ratio also changed in terms of its range. So what we were advocating
Hi, everyone. I just wanted to let you know, yeah, we are seeing the technical difficulties of what's going on. We're going to try and figure out what happened. I'm not sure if Dr. Peoples' battery died or what, but we'll go ahead and we're going to see what's try to figure out what's going on. If you have any questions, if you're having any issues with the Q&A, you can go ahead and put them in the chat, and we'll try and get him back up online in the meantime. But if you have any questions for Dr. Peoples, we can put them in the chat, and if we're not able to get him back up, we can send those questions on to him and have him get back to you. So bear with us just for a few minutes and we'll see what's going on. Oh, I think you're mute. Oh,
How's that?
better. Yeah, you're back. Okay.
we just had a blackout in the building.
Oh my goodness. Okay.
Sorry.
Oh, no worries at all. I'm glad you're back up.
Hang on.
Do you want to go ahead and share your slides? Thanks everybody for sticking with us.
Are we good?
All
Can
right.
you see them again?
Yep, you're all good. Go ahead and keep going.
All right. So where we're up to, sorry, we just had a complete flash out here. What we're up to is the idea that we can see that there is very much a compliance issue in the real world. So in other words, those athletes that take on the education, get good change, if they're effective in actually taking on 7-day-a-week incorporation of the fatty acids, they get the best outcome. Those athletes that don't engage pretty much don't get any change at all. And this is the point I want to make, is that in the real world with real athletes with lots of choice, they don't always engage. So education is a really important part. Part of this is we've continued to screen the Australian athletes in this instance. And you can see here we get a good scattering of baseline data with some athletes already in high omega-3 status. But we've also got evidence that athletes are still needing increased intake in this instance. So what we've done in the last year is actually provide provisions of food and supplement omega-3 testing. And we're seeing some good examples here that we've got a relationship between the number of fish meals that are consumed and the supplement intake at any one time. And so obviously when we push forward, what we can see is that from a self-report point of view, 2,000 milligrams minimum target seems to be the minimum to be able to push that up. And what we've also got here is all those here in black are taking a supplement. So although fish provides a good baseline background part of the diet, taking a supplement also is a really important part. And again, this dose is starting to push up towards 2,000 milligrams. This is some work I've done with Marcel. So this was the comment around some professional cyclists in this instance. And so we were able to screen them prior to any major educational or formal education. And this group was actually quite high on average. And you can see the scattering from those that were above 8% and those that were below 8%, but on average it was around about 7%. And we had a look at that in terms of pre-grand tours, omega-6 and omega-3 and the AA to EPA ratio. And you can see that, with a good background diet with already provision of fish a couple of times a week, we've got a good basis to be able to advise that, on top of that, we can take some omega-3 supplements. So this was a study that we did where we provided evidence and also education to take supplements over the course of the season. Those that achieved those recommendations were higher compared to those that did not, and they stayed the same around 7%. So this idea that not every athlete will engage is a really important conversation to have, and then it's a matter of being able to work through why that's the case. This is again some work I've done with Marcel in the Netherlands, and this is a track athlete that we have been looking at following the omega-3 index over a longer period of time, and so this was prior to any formal omega-3 supplementation. So the baseline of particularly fish meals was around about that 6 or 7%. But we've introduced sort of 2 phases in this instance. If we have a look at the provision of fish oil and a provision of algal oil, we can see that we can raise that over a longer period of time. And what's interesting is if we then have a look at the intake over time on average, the combination of fish and omega-3 came out to be around about 1,500 to 1,600 milligrams per day in this particular case study. The other thing I just want to point out that's really notable in here is that the bars in the orange and the yellow are showing off-season. And the difference now is if you raise the omega-3 index and go into the off-season where the diet changes a little bit, the reduction that we see in these particular indices, whether it's omega-3 index, DHA, AHA, EPA, is coming from a higher baseline, and therefore the athlete can then re-engage in the next part of season from a higher baseline. So it's really important in terms of demonstrating, going back to Clish McGorry's work, that the washout is evident, but if you're doing it from a higher baseline, then you've actually got a good starting position for the next particular season. So if we put that on the map, what we can see is just a range of different doses starting to fall out, but the common theme is that it's over 1,000 milligrams. Okay, so and the other common theme is that the longer the intake, the more that potentially will settle out between 1,500 and 1,600 grams, and that the shorter intakes in the bigger athletes potentially might have to be a little bit higher. What about the plant-based athletes? So this is some work we've done demonstrating that when vegan endurance triathletes, and when we say vegan over 12 months or more, are screened for their omega-3 index and AA to EPA ratio, they are worse off than the classic omnivore background meat-eating diet that you'd see in the Western style diet. And we've done some work where we've sort of been able to look at the combination of whether the difference between a tuna-based or an algal-based supplement that again provides DHA just tipping over that 600 milligrams can have an impactful mark on the omega-3 index. So here's our classic sort of scattering of our baseline endurance runners in this instance, and that when we provide DHA at that 500 to 600 milligrams, we can see that it didn't matter whether it came from a fish-based or an algal-based supplement, we get a same sort of effective change. So there is definitely, from the point of view going back to the sports supplement market, definitely an increased ability for that market to start to look for alternatives beyond simply fish oil. And the plant-based athlete will have alternatives going forward that they can use in terms of algal. Last couple of slides, and apologies that we sort of ended up with that little dropout, but we've done some work with large sporting teams here, and part of that is to come up with kind of an omega-3 program for them when you have 50 or 60 athletes. And so what we do in this instance is we look towards a couple of different phases, so a pre-season phase and a season phase, and we go through a couple of sub-phases where we load the athletes, we check their omega-3 index, we provide biomarker feedback specifically to the athletes, and then we recheck them, and particularly for the athletes that are not responding or are non-compliant in this instance. So in other words, what we've demonstrated is using the omega-3 index is a really good way of interacting and educating with the athlete, with the sports dietitian, to be able to increase the provisions through both supplement and whole foods at any one point in time. So, quick summary, 3 decades since we saw our first study in VO2 max for aerobic athletes. We've seen a rapid expansion across the body systems. I think we need to really start to learn from the cardiovascular body of work around eliminating research waste going forward. The omega-3 supplement industry is also rapidly expanded, and we can kind of see that they've really targeted skeletal muscle in this instance. But I think, again, going forward, hopefully with increased evidence around SOR meta-analysis, that can also span back to brain and heart and cardiovascular system and all these other systems. We definitely know that the omega-3 status of the trained population is low to moderate, but working and educating with sports dietitians can have some impactful change is our position in this instance, and it's about the long game rather than just simply short-term supplementation. It's about education to change and behaviour change around diet and the sports diet in particular. In terms of onwards, I've broken them into 3 groups here. So I think we're leading around heart rate, muscle soreness responses. We're also leading around better understanding of the doses for omega-3. I think our emerging pathways with pro-resolvins will be around inflammatory-based responses. That will relate quite nicely to some of the brain injury and soft tissue repair. But I think our future work has to be derived around sort of separating EPA and DHA on a more on an increased basis, and looking at doing some really good studies around the physiological processes of sleep, immune cells, gut metabolism, and so on. And even though, and I'll just come back to the last point, even though the majority of thematic reviews have been around physical performance, at this point, we actually don't have any evidence at an SLR meta-analysis to say that physical performance per se is increased. So I think we can also look more particular around that and sort of start to get some decent evidence. So currently we only have 10 meta-analysis across the range of themes, but we need some careful construction so we don't end up in this area of research waste. So Jeff and I put it recently, fishing in muddy waters. We need to really reel in the methodological flaws of Omega-3, and hopefully we can really make some impactful change in the industry over the next decade. All right, so that's us.
Thank you so much, Dr. Peoples. That was just incredibly thorough and just really interesting to hear all that history about omega-3 research in the sports and performance space. We've got a few minutes for questions. It looks like maybe we're having a little bit of trouble with the Q&A, but if you can submit your question to the Q&A, we'll do it there. But if not, you can put it in the chat. If we don't get to your question, we will forward it on to Dr. Peoples, and we'll have him, respond, and we'll get back to you with his answers. So the first question, can you talk a little bit more about the DHA EPA ratios and the dose for head injury prevention? Is there a trend, or is it still early to make recommendations?
Yeah, so first comment on that, and we've seen evidence of the industry treating it as a post event supplement. So in other words, game happens on the weekend, head gets knocked, we'll give the DHA or the EPA the next day, or the fish oil more broadly. I think the conversation is starting to turn around to the idea that longer term provision is actually going to be where the evidence sits. But what we've got at the moment is Jeff and I managed to sort of wrangle together some data from 3 different studies, but we've got an RCT currently under Tim Mickleborough going ahead in the US, and they're using a really interesting model in that it's a high DHA. It's provided for the classic period of time of 2 months before, but they're using a soccer all heading model to be able to deliver repeated control head knocks over 2 consecutive days, and then looking at the recovery and inflammation. So to be honest, I think it's really early days. That will be the first proper RCT with a controlled laboratory environment, and they're recruiting over 100 individuals in both the placebo and the control. So I think we're at a stage where we can say that the hypothesis should be long-term intake. It's likely that DHA will play a really critical role in that, but it's going to be about 18 months before we get our first proper study that actually gives a outcome related to neural inflammation, for example, or symptoms, or brain scanning that we can say that DHAs have an impact. So I think it's a wait and see on that one at the moment, but it doesn't hurt in terms of being able to still provide omega-3 on the basis that we know it's good for brain health, full stop. And so hopefully we see a similar theme to heart and to brain in terms of being able to protect in those injury states.
Awesome. All right. So next question. This question is actually from Bill Harris. In your real world studies of the effects of omega-3 supplements on the omega-3 index, did you compare the observed change with the omega-3 index calculator predicted change?
We haven't yet, Bill, but we are. So the study that we're about to publish will have that as part of it. At this stage, it's not an exact science, like but we see good, decent variation between individuals. It will still, in my mind, still reinforce the idea that we do need to take bloods on a consistent basis in athlete groups to really be assured. And I think the other important part with that is that what we've observed is that sports dietitians then have, and this is where the omega-3 index has been fantastic in Australia, they actually have a conversation that they can have with the individual athlete. And that actually opens up individual education on an individual basis for food as well as supplement intake.
Yeah, it provides them something sort of to teach to, right? They can say, hey, you're actually moving this marker, and gives that feedback to the athlete. It's great. So next,
Sorry, Kelly, the other comment
oh,
we
no,
make
it's
on
all right.
that, athletes are really competitive, so they want to get the highest score possible.
Yeah.
That's the other
More is
observation we
better.
make.
So next question, excellent presentation and very exciting news regarding the potential role of DHA and EPA in DOMS. In this case, with the relatively high doses, greater than 2 grams of omega-3 per day, have you seen or do you anticipate higher instances of AFib, atrial fibrillation, with those high
So
doses?
yeah, the answer broadly is no, because I don't think we need to go to very high doses. And that's the other really important part. I think with the long-term intake, and particularly around DHA rather than EPA, we can be in the range of omega-3 long-chain intake that's not associated with any of those reports that AF is potentially, I'd say, an issue. So in other words, I think DHA potentially is going to play out as the more important versus EPA in the DOMS area, particularly around the area of pain. And then if you look at it from the point of view of which of those two fatty acids potentially are associated with AF, well, we know DHA is heart rate lowering and antiarrhythmic in a lot of different ways as well. So it's a combination. The dose doesn't need to potentially be up at 3, 4, 5,000. It could sit nicely around that 1,000 milligrams if it's taken in the long term, is the answer there. So the answer is no.
And then last question, another one from Bill. How do you know that the poor change in your omega-3 index in your ad-lib study was due to poor compliance? Did you do pill counts?
Yes, we did, Bill. Yeah, so we were able to, being in that environment, the way that the athletes are provided it is that they are literally provided like a Webster pack, but they're not forced to take things. So in other words, they get given stuff every day, it goes into their trays, but then if they simply don't take it, it's there in the tray to count, and we're able to count it back. So we could see that those were taking every day versus those that were just not taking it all.
Great. Well, thank you so much, Dr. Peoples. I think that's it for the questions. Thank you so much for such a great presentation. And everyone, thank you so much for attending. Coming up is our next and final session. This is our live panel discussion with several of the presenters from this week, including myself, Dr. Bill Harris, and Dr. Heidi Lai. We're going to tackle everything from brain health to omega-3 sourcing and everything in between. We've got a lot of great questions that have come in this week. We're going to try to answer some of those. And thank you so much for joining us today. And hopefully we'll see you at the next session. Thanks again, Dr. Peoples.